Hey everyone, this is Derek, and in this video we're going to look at solving linear applications involving cost, revenue, and profit functions. So we're going to see these definitions for the rest of the quarter and actually into the quarter after this also if you go on to 148. So these are good things to be comfortable with. So C of X, that's going to be our cost function, or the total cost to produce the sale of X units. So our X is going to be always units. And notice our output is money. So we're putting in a number of things we're going to make. We're going to get out money. So our total cost is going to be, at this point, the sum of two things: our variable costs and our fixed costs. So fixed costs are going to be things like rent. So say you pay $1,000 to rent some space to make your things, whatever these things are that you're going to sell. So that $1,000, whether you make any things or not, you owe them $1,000 for your space. So that's a fixed cost. And then whatever these things are that you're going to make, say it costs you $3 to make each one of them. So then it'll be $3 times the number of units you make, $3 per one, plus that $1,000 in rent. So that's sort of the idea of a variable cost and a fixed cost. Fixed cost not affected by the number of units you're making. Variable cost is the cost to make each unit without the set part. And so we can kind of think of that as the cost function, or C of X, is going to equal the variable cost times the number of units X plus the fixed costs. Revenue. So revenue is how much money we're taking in. It's not how much money we get to keep. That would be profit. But revenue is like our gross. So that's going to be capital R of X from selling X units. And revenue is simply the price per unit times the number of units we sold. So if we're making these things and they're $3 and we're going to sell them for $10, then our revenue would be $10 times the number of units we sold. The $3 and the $10, that comes in at profit. So that difference, that's your profit. So your revenue, that's the $10, it's the total. The cost, that's how much you had to pay. And then profit is revenue minus cost, 10 minus 3 per unit in this case. And so we'd have a profit of $7 per unit. And we'll do this with, entire functions, but just to try to get a sense of what the words are. So how much we pay to make it, how much we get paid when we sell it, and then the difference. Also profit, right? It could be negative. It could cost us more to make a thing than we were able to sell it for. In which case our profit actually be a negative value. Break even, and profit being negative totally happens, right? Because if you think back to my example here where the fixed cost is $1,000, if we haven't sold any of these things, I owe someone $1,000. So I have not hit my break even. I'm going to need to sell a whole bunch of these little widgets to get me up to that $1,000. So break even is going to be where revenue equals cost, where the money you spent equals the money you took in, or same thing, just a different way of coming at it, when profit is 0. And you'll see if you move that over, it's the same thing as saying cost equals revenue. Okay, so that's our definitions. That's the toolbox you get to work with. And then let me show you what that will look like with some examples. Okay, so this example goes, a sports franchise revenue could be modeled by the function R of T equals this. And then their operating costs are modeled by the function C of T equals that. Where T is the number of years since 2008, and both R of T and C of T are in millions. Find the profit function. Okay, so for profit, remember from our last page, that is where profit as a function of X is going to equal our revenue minus our cost. And so profit is going to be our revenue function minus our cost function. And this set of parentheses isn't necessary, strictly speaking. I'm just kind of trying to say, here's R, here's C. This set of parentheses is totally necessary. Remember, there's this kind of invisible 1 that should be happening that's going to subtract this 24T so that it's not adding, it's subtracting. And that is important. So P of X is going to equal 350 minus 240. So that's going to be 110. And then 10T, and now this is minus 24T, so minus 14T. Let's see, for this one you decide to begin selling frozen bananas at a local fair. Your cost for each banana is $1.23, plus you have to pay a fixed weekly fee of $120 for the booth. Your plan is to sell each frozen banana for $2.85, And then we're going to start writing a bunch of different functions for it. So first off, we're going to write cost as a function of n to represent your total cost for the week if you sell n frozen bananas. So they're using n as number instead of x, which is totally fine. You'll see that a bunch. So C of n. Do be careful though that like when you type these things in the computer that you don't use x, that you use the variables they gave you. And then anything that's a capital is case sensitive should you need to type that. So C of n, our cost is going to be, we're going to spend $120. Whether we make any frozen bananas, sell them, whatever, we owe someone $120. And then for each banana we make, we're going to have, that's going to cost us $1.23 times the number of units. Next, I'm supposed to write a revenue function to represent the sale of n bananas. How much we selling? So $2.85 is our sell. So that's going to be R of n equals $2.85 times the number of units sold. And then write our profit function. So again, profit is going to equal revenue minus cost. So that will look like 285 n minus our cost function. Again, those all important parentheses, because otherwise, let me get this written. I'll show you. Without those parentheses, all of a sudden my cost is only $120, and then I'm somehow gaining $4 and some odd cents, 8 cents per banana, and that makes no sense, right? Because we have to have these two values. This is my cost per banana, this is my sell, so that difference is going to be my profit. So do have to be careful with the parentheses. So P of n, 285, that's going to be 162 n minus 120. So if I sell no bananas, right, I still owe someone 120, and then for each one I sell, I'm picking up $1.62. How many items do I have to sell to break even? Well, if my profit is 0, I have broken even. So basically, I need to cover that $120. And let's see, that will be 0. Add my 120 over, and then divide both sides by the 162. Oops. And I got n to equal, so it came out on my calculator 74.07, but that means that 74, right, I haven't broken even yet because there's still a little bit left. So when do I actually get past that break even point will be with the 75th item. I'll have more than broken even, but the idea is how many, if I only sell 74 units, I didn't break even. If I sell 75 units, I broke even plus, so I met the criteria. Okay, so here we have, let the demand function for a product be given by D of Q equals this, where Q is the quantity of items. So now it's Q instead of N instead of X. And D of Q is the price per item in dollars that can be charged when Q units are sold. Suppose the fixed costs of production for this item are $3,000 and the variable costs are $5 per item produced. If 36 items are produced and sold, find the following. Okay, so first off, we're supposed to find the revenue. Let's go back to this thing and say, so this is a demand function. So when Q is the number of items produced, the demand D is the price of the item. So there was kind of the key word. They don't want to call price P because that makes it seem like profit. And so they're calling it the demand of Q, which is going to be a price. So as the number of items that are available changes, then the price that people are willing to pay also changes. So here, our revenue, yes, revenue as a function of Q is going to equal, and remember from our definitions, it's how much you're charging times the number of units, price times units. So D of Q, this does equal, that's our price. So this function is price. And then that's times Q. Sorry, my cues are terrible. My handwriting's terrible. And so I'm supposed to find the revenue from selling 36 units. I could distribute this through. I could also just find R of 36 right now, which is what I did. And so I just tossed 36 in here and here, and I think this comes out 2.016 times 36. And so what this is saying is this is going to be my price at 36 units. And so if I get to charge this much and I'm selling this many, that's going to make 7257.60. So that would be my revenue to the nearest cent for selling 36 units. And so that's part of why I didn't distribute this, so I could kind of show, here's our price and then here's our revenue. And you can see as if there's none available, as the thought experiment, someone out there's willing to pay $270. But then as each one becomes available in real life, you're losing $1.90 each time off that price. So the more available it is, the lower the price is. Okay, so for part B, we're supposed to find the total cost to produce 36 items to the nearest penny. So cost is a function of Q. We come back up here and our fixed cost is $3,000. Our variable cost is $5 per item. So 5 times the number of items plus 3,000. And this is a cost, so that's a plus, right? Because we're adding up, we're figuring out, it's negative money, it's how much we're going to spend, but we're finding the total cost. So now I can just find C of 36. And so I just evaluated that at 36 and got $3,180. And then lastly, I'm supposed to find the profit to produce 36 items, and it may or may not be negative. So right up here, remember profit is R minus C, and I don't have to do it with the equations because they had me find the values. So it's just the 7257.60 minus the 3180. And so our profit was $4,077.60.